welcome. We'll just wait a little bit to let people filter into the meeting. In the meantime, maybe people could tell us what time it is in your local time zone, just so we see what time it is for you. It's 8 a.m. Pacific time. I just got up.
Good morning.
Morning. Wow, 11 p.m. That's quite different from here. I drink my pint of coffee. Yeah, a strong international crowd here. That's cool. Baku, that's Azerbaijan. Let's give everyone a couple more minutes. Someone in the Americas, maybe two. Houston and Argentina. Wow, cool. Shall we start? The numbers of people have sort of started to slow down. Yeah. Well, welcome everyone. My name is Gareth Funning. I'm a professor of geophysics at the University of California, Riverside. It's 8 a.m. where I am, or just after. And I am one of the lead instructors of the course. The other lead instructor, Franz Meyer, is on a plane, so he is unable to join us today. He's been in Alabama for something NASA related, I think. And I've been doing InSAR for 25 years, and that sounds like a long time. And I've been an instructor on this course since 2017. So I've been doing this for a while, but the last few years have been really great because we've had the opportunity, through basically forced at the beginning by the pandemic, but then we did it deliberately since then, to offer this course over Zoom, which gives us a much more global reach than we previously had. And the evidence of that seems to be the number of different places that you all say you're coming from in the chat, which is fantastic. Okay, so with me on the call is Melissa Weber. She can introduce herself.
Yep, Melissa Weber. I work for EarthScope Consortium. I'm the Community Engagement Coordinator. And my job is to host and be the logistics background person for all the short courses and other events, live and virtual. I also organize and maintain the memberships for EarthScope and the exhibit booth.
Also on the call, it seems we have Ann Chen, one of the instructors.
Hi everyone, I am Ann Chen. So I will be an instructor for 3 of the session next week. So very nice to meet you. I started to do InSAR processing since 2008 when I entered the grad school. And back then, like if you're processing 300 interferogram, it was a really large data set. And since then, the technology and the field has rapidly progressed, and that's where we are today, working with thousands of interferogram and a much larger community. So it's I'm grateful to be able to connect with all of you through this class, and we'll have more interaction next week.
Great. Yunjin is on the call too.
Hello everyone, I'm Yunjun Zhang, a researcher at the Chinese Academy of Sciences. I will be with you today mostly on Friday, on the last day on the time series. And I will be show up mostly shortly on the evening office hours. My first InSAR starts with interference already back at 2011, when I was trying to use stories and stamps on some data set in the Three Gorge Reservoir in China, a very vegetated region, and running on MVSat. And luckily right now we have Sentinel-1, and I'm really looking forward to work with the new NISAR data, which I believe will be much, much better on the regions like this. So I'm really happy that we're going to the area of time series.
Yeah. Scott is on here too.
Hello. So I'm Scott. I was Ann's first PhD student. So I also learned through the Howard Zepker lineage. And so I was at University of Texas. I finished 3 years ago in 2022. and I joined the SAR algorithms and processing group at JPL. So I'm currently at JPL, and I've been working mostly on the Opera project. So that's a project which has surface displacement as a routinely processed data product over North America. And we're going to look at that later in the week, and we'll also go into the open source library Dolphin that is kind of the underlying algorithms that's driving it. And I've worked with the ISCE algorithm development team, although it's kind of a lot of overlap between the people who made the algorithms for the co-registered product of Opera and the geocoded SLC product that ISCE is going to deliver.
Which is deliberate, right?
Yes. Synergy.
Yes. And I saw Sarah was on the call. If you would like to introduce herself too.
Yes, hello. I'm Sarah. I'm also an InSAR person. I graduated in 2022, and then I joined Caltech and JPL. I'm working also on Opera, and I'll be with you next week mostly.
Thank you. Great. So this is just a subset of the instructor team. It's very hard to get us all in one place at the same time. We're also from a range of different time zones. But you'll see many more people next week chiming in with different aspects of the instruction, which is what I'm here to tell you about today, like what we're doing in the course and when and what it is. So the next thing I can do perhaps is take you on a tour through the various resources that we have put up on the internet for you about the course. Maybe I'll start by sharing a browser window so you can see what I'm looking at. Can people see this? This is the document with all the lecture details, all the Zoom connection stuff. And you presumably have accessed this document, presumably to get into this course, to this call. And there's a couple of things I'd like to show you. One is the Slack for this course, which if you click through all this, you should end up in a place where you have all this stuff available to you. This is the primary means of communication between people who are in the course and us instructors. If it doesn't happen in here, we might not see it. You do have the opportunity during these live sessions to talk to us through the Zoom chat. But if you want to talk to us outside of these sessions, the Slack is the place to do it. And specifically, the most important thing probably to know at this stage, in the sort of what we call the pre-course phase of the class, is that if you are having trouble getting onto the online system called Open Science Lab, you post about it in Slack, because that is where the staff at the Alaska Satellite Facility who are maintaining that system, that is where they are looking for people requesting help. Okay, we'll talk more about Slack things later on, probably. The other thing that we have for you that's linked through this document is Moodle. Moodle is a course management system. So you can, in here, you can access what we have set up for you for the course online. Right now, there's a limited selection of things for you to see, but this will grow over time. And what's listed mostly here at the moment is a collection of activities that we call the pre-course. These are things to complete before the course starts. The course starts, of course, next Monday. So you have today and the weekend to get through these things if you haven't looked at them already. And probably most importantly of all these things, there is a quiz, which is listed under here as InSAR ICE+ course pre-assessment. If you click on that, you can basically go through and see that there is a quiz for you to answer. And 67 people have done it. Well, that's basically about just over a third of the people that are registered for this course. So there's plenty of people who haven't done it yet. And the point of this exercise is to find out what your level of knowledge is about SAR and InSAR and the various methods that we will be teaching you about in the course. To find out what your knowledge level is before the course starts, so that we can tell potentially how well we have taught you those things by the time the course ends, when there will be another assessment like this that you have to complete. So that's up there, and please go in there and do that. Also linked in here is the course syllabus document. So if you go to this link that says syllabus, you can see the syllabus is corralled in a tiny box. This is a Google document that contains basically live updated information about stuff. There's also a link to this document in this little window, and if you click through on that, you get to see it in a bigger form, which might be more useful. Okay. So we will go through this document now because there's a few things to point out. Okay, so first we start with an instructor list. Hopefully this is up to date. If there are instructors who feel that they're missing, they should let me know, and we can make sure they're represented here. Then there's an overview of the course, and it basically makes a few points. And one is that the course is divided into 3 sections. There's the pre-course, which is the stuff from which is before the course starts in full. This is mostly a series of self-paced, self-learning exercises, and getting you up to speed on the online system and things, and completing the pre-course survey that I just showed you. This assessment of your knowledge coming into the course. Then starting on Monday, we'll have the main course, which runs for 5 days, with what we have scheduled as 4 hours of time every day. And then after the course is complete, there are 2 more things for you to do. One is to complete a post-course assessment on your knowledge, and the other is to fill out a survey that attempts to get at your learning experience on this course. And we would like you to do all of those things so that we can track basically what you have learned and also how you feel about the experience. And we use those things, of course, to guide what we will do in future and revisions to the course and all sorts of things. And this year it's important because we've actually added quite a lot of new things to the syllabus that we haven't taught before. So we're really curious how those things will go down. There's also going to be, and we haven't posted it yet, some supplementary materials. These are things that that we have previously taught in the course, and they're still good materials. It's just that we don't have time to cover all of them in the live sessions. So what we're going to do with them is provide them again as sort of self-paced learning and optional extra things for you to look at. And we'll also provide the videos of the sessions from the previous versions of the course where we offered those, so that you have some context for the materials and all the extra value added by our presenters of those things. So we'll get those up and running for you soon. And they include things like different modes of processing data, like different algorithms or workflows that we have used in the past, some information on manipulation of the data once it's processed, and some application-based things. Like there's a lecture about using InSAR in the study of the cryosphere, like study of ice movement, which is really cool. But we don't have that instructor on our team this year. So that kind of thing. Let's see what else. So this paragraph here talks about how we are going to run this course on an online system called Open Science Lab, and we provide a link to it. And the advantage of this Open Science Lab system is that it's a completely sort of closed environment where we control the installation of everything, so that everybody gets the same installation experience. In other words, they don't have to do anything. It's all installed. All the software is installed for you, and all the course materials are downloaded to that system for you as well. So there's nothing for you to do other than log in. The reason that we really like this system is that when we offered this class in the past, people did not have access to a system where all the stuff was installed for them, which meant we had to help them install the software on their own computers. And that just took up like a whole day of the course. So that's why we're not doing that anymore. Of course, at some point you will have to install it on your machines, but we hopefully will have got to the point where you've learned what all the things are for that, and we will provide some suggestions and instructions for how you install the software yourselves towards the end of the course. Here we have a link to the Open Science Lab. If you follow that link, you should find yourself at a place like a page that's a bit like this. I mean, this is showing me that I already have an account that's registered with the people at the ASF, the Alaska Satellite Facility. So I can go straight through into the environment for the course. Many other people, though, won't have this when they start out. If you find yourself logging in and having to make an account, and then by the time you manage to actually get through those first steps and click through into Open Science Lab, and you don't see a box at the bottom describing the 2025 EarthScope InSAR workshop, which is what we are in here, then you'll have to go onto Slack here. And like all of these people you can see on here who are messaging these two people, Eric Lundell and Dylan Palmieri, those are the two helpers, the staff members at ASF who have been helping everybody get access to that particular page and that particular have that particular thing come up for them. So on here, you would post basically what you signed up as your username for the Open Science Lab with, and then they will be able to grant you access to this. So what I have, once you click through all this, you'll end up hopefully in a place where you can edit and interact with some of the teaching materials of the class. And this is what I was testing yesterday. One of my exercises from I think it's from Tuesday afternoon. So I was running through these notebooks and making sure they work. And it works. Awesome. We have a whole recorded session led by Franz Meyer yesterday on how to do all these things. So if you're seeing me doing all this clicking around and logging in and it sounds completely alien to you, I highly recommend you go back and look at the video of the live demo of this. We don't have time to do that today. We have a separate session on it, and as I can see, as I saw when I was like idly surfing through Slack, Melissa has actually posted that video. So if you click through here, oh yeah, there's a video and you can watch it, and that will be great. Okay, back to this. What else have we got? So, okay, this is a discussion of the Zoom sessions. The Zoom sessions are 4 hours long. We used to offer an in-person course that had 8-hour days, but we can't really spend 8 hours on Zoom a day. We would go slightly crazy, I suspect. So what we have done to make up for the sort of the lost time element, like we used to fill those 8-hour days, is to ask you to do some of the work yourselves at your own pace offline, well, online, but not on Zoom. So we have a series of homeworks associated with some of the activities that we're going to do, and those you would complete yourself, and then there are spaces on the Moodle system to upload your homeworks if you so wish. Well, not that you wish. You will see eventually that there are places where you can upload your homework results on the Moodle system, and that is a new thing that we're trialing this year, so that the homeworks are collected in one place where we can easily grade them, and the grades are tied to a grade book, so we can actually keep track of who has done what. So all of that is new for 2025. We are trying this new course management system. So hopefully we've worked out most of the bugs, but have a little patience with us if we have not. Okay, next in the syllabus document, we have a collection of links, many of which I've already clicked on for you of things. So we have a link to the course website, which is where you would have signed up for this course. This is just the EarthScope webpage. This is the link to Moodle. This is a link to the Jupyter, the GitHub repository where all of the Jupyter notebooks and materials for the course are slowly accumulating. You'll see that there are a whole bunch of numbered folders in here. The things that are start with a 0 are pre-course materials. Then basically everything else is numbered by the day of the course. So everything that starts with a 1 is from day 1. Everything that starts with a 2 is from day 2, and so on. This is here basically what we're sharing it with you because you will be able to come and get these things yourselves. After the course is done, you can clone this repository and you'll have a copy of all of the materials that we used in the course. And this is actually where the Open Science Lab grabs all the materials and downloads them to your instance on Open Science Lab. So hopefully that will be a useful resource for you in the future, that you can actually get hold of every single thing that we covered in the course. Let's see, what else have we got? We've got a link to Open Science Lab, we have a link to Slack, and there will be a link to YouTube here. And we live update this syllabus document so that when new information and new things come available, a link to those things will be pasted here, and we will start. The YouTube videos are just become available this morning, and we haven't had time to actually put the links in here yet, but that will happen shortly. All right, next in the document is a description of the pre-course. So we have placeholder information saying that this is where we'll put the Open Science Lab information video that from the session we had yesterday. We had a kickoff meeting like this one yesterday, and we'll also put the recording for that here. We have a mention of the pre-course survey, right? So like stuff I've already talked about. And then the rest of the pre-course materials are all on the Open Science Lab. So if you had this thing up and you have access, you'll see a link called 2025 ICE Plus. And if you click through to that, you get access to all of the pre-course notebooks and all the course notebooks and things that have already been uploaded here. So for example, if you click on 5, you have two of these notebooks here that you can open. And I've chosen these ones because this particular one, data access and accounts, is the one that we care the most that you complete. I'll get back to the syllabus here and show you. So basically we have 5 things. We have a module on math basics. So the sorts of math that we talk about in InSAR, typically it's complex numbers, trigonometry, and vectors. There's some other things as well. And if you follow through this notebook, there's both sort of revision material describing all the different things, and also some little self-guided quiz questions where you can answer a quiz and test your knowledge. There's also a series of notebooks that just describe aspects of Python and Jupyter notebooks and NumPy and Matplotlib, which are kind of ubiquitously used in this course. NumPy is the module in Python that allows you to handle large number arrays, and Matplotlib is a plotting system, and a lot of the notebooks that we use in the course use those things. So that's just some background. You may or may not need that background, but we thought we'd provide something in case people were curious. This third thing is information on the theory of SAR, and specifically on some of the underlying concepts of SAR phenomenology. So some of the things that we talk about in in passing are defined here. So speckle and the effective radar wavelength and the radar equation. And we don't really talk about polarization so much, but we might talk about layover, shadow, and foreshortening as sort of geometric phenomena that affect SAR imaging. And all of that is described in this notebook, which used to be part of the main course material, but is one of the things that we have pushed into the pre-course to save some time. So there is a video which is old of this being described in a bit more detail if you're curious. It's a slightly older version of the same notebook that's used there. This fourth thing is describing accessing and working the Open Science Lab. This is basically following the video from that was recorded yesterday and trying to do some of the things that are demoed there yourself. And the fifth thing, which I opened up for you or to show you on my system, is data search and access. And of all the things, if you can get access to Open Science Lab and get in there, of all the things that you can do and that start with a 0, this is probably the most important, because this is where you're encouraged to set up accounts for things like NASA Earth data and Open Topography, which are 2 suppliers of data that we need to actually run some of the course materials. NASA Earth data, some digital elevation models, but more importantly, the SAR images themselves require those credentials. For Open Topography, other digital topography data that we use in some places is enabled by having an account on that. But it's not enough just to set up accounts on these 2 things. You also have to test whether you have given the correct permissions that you have to sign. You have to basically acknowledge like a terms of service agreement with NASA if you want to download Sentinel-1 data. Actually, that terms of agreement is with the data provider in the original data provider, which is the EU. If you don't have that agreement, then you still can't download data, even if you have the account. You also have to set up 2 files on the OSL system called .netrc and .topo-API. And if you don't have those, then some of the other things won't work. And those files contain your credential information. So anyway, this is just to say that if you do one thing in the pre-course, please make it be this. And in this notebook, the data access accounts notebook, we give you links to all the places where you sign up for all these things and how you make these files. You have to actually edit some of these code cells to put some of your own details in here. There's a thing to log in my username. Oops. That you need to swap out your actual username for this my username and your actual password for this my password and run that code cell, and you will set up one of the files. Then this other thing, the search and download test notebook, actually gets you to try using those credentials. First by searching for some data to download, and then actually trying to download it. And there's a series of things to go through to make sure that they actually all work. And if you have problems with these things, the thing to do would be to post about them in the Slack. And those of us who understand how to get these things working can try and help you here. Okay, that's the pre-course. Then, okay, well, we have 5 pages on the syllabus document, which just cover all the things that we're going to cover over the course of the week. 1 for every day. So the big headlines, I guess, we start on Monday with introductions and a recap of the OSL system. And then we're going to have sessions on geophysical modeling with geodetic data. So we start out with kind of perhaps the end goal of the course, which is getting you to use the data for some earth science purpose. We'll show you an example in this part 2 of this module, which is modeling data from a volcano in the Aleutian Islands and trying to understand something about that volcano system. Then in afternoon Pacific time, we'll have Anne talking about InSAR theory, a lecture where she will take you through some of the key key theoretical underpinnings of the things that we're showing you. And then I will lead at there's the last exercise of the day, an interferogram interpretation exercise. So you take an interferogram and try and understand it, try and interpret it. There are 2 homeworks. One is related to the modeling exercise, and the other is completing the interpretation exercise. Day 2. Interesting. If there are any questions, please use the chat or unmute yourself and ask. I can handle either, although the chat probably will be better monitored by somebody else because it's hard to see when you're presenting on Zoom. Day 2 is mostly devoted to using the processing workflow that we call TopSAP in the ISCE software, which is the workflow that allows you to process Sentinel-1 interferograms. This will be led by Eric Fielding, and this is how you learn how to make interferograms, which are the kind of the basic unit of InSAR these days, or have always been. But it's increasingly important now to process large volumes of interferograms. However, there's still a lot of value to knowing how to process one, and so we will show you how to do that. The other exercise of the day will be taking the output of InSAR processing and modeling it, or at least preparing the data so that they can be modeled. We have a series of routines that show both making forward models of earthquake deformation, just as an example, and then taking the data and sampling it, and running an inverse model, which we go from a data to a series of model parameters describing an earthquake and how you would go about doing those things. And one of the key things that we cover there is really the downsampling of interferograms. Interferograms are made of millions of pixels. You don't need to represent millions of pixels in order to use that information. We typically sample a few hundred pixels or a few hundred data points from this large data set. And the reason we can do that is that the data are highly spatially correlated. You don't need every single pixel, because basically in one area of the interferogram, all the pixels will have a very similar value. So you can just represent that as an average of those values. Anyway, I'm getting ahead of myself. We'll talk about that on Tuesday. I did forget to mention, and I can show you now, that there are times set aside in the morning and evening Pacific time for office hours. So these are times when a number of the instructors will be available on a Zoom call like this one for you to ask questions and to show your results, potentially to get your problems addressed, and various other things. One of them is at 8 a.m. Pacific, 7 a.m. Pacific, sorry, 7 till 8. So if this sort of time period is good for you, if your time zone is good for the morning Pacific time, this would be your better session. There's also one 3 hours after the end of the course every day in the evening Pacific time. And for those of you who are for whom that time zone is more appropriate, of course, that will be the time to come and see us. And there will be different instructors on the morning and evening, because the instructors themselves are more comfortable in one of these time zones than the other, probably. Yes, there will be homeworks again that are linked at the bottom of that page on the syllabus. On day 3, we have some time series theory in the morning, led by Anne and Scott. We will have a discussion or a description or an exercise talking about the inputs to time series, which are stacks of interferograms, and how we go about getting hold of those, and what we do with them. And then another module at the end here talking about sources of noise in interferograms. So like what the sources of noise are, how they affect the data, and what we can do about them. Day 4, we have more information on starting out on SAR missions. So the different satellite missions that are the sources of the data that we can process, and what some of those those are. We'll have a module on measuring dense offsets between SAR images. This is a way which is not strictly InSAR, but it's definitely related and can be done with the same software. This is a way of measuring the distortions to images that are caused by large movements. So this is particularly suitable for large moving or fast moving glaciers, but you can also use it to study earthquakes and volcanoes and other processes as well. We'll have a module on what you do, what you can do with data from multiple lines of sight. If you have multiple interferograms or multiple time series or velocity data sets, often you will have data from different viewing geometries, which means different orbits of the satellite. And we often talk about ascending and descending viewing geometries in InSAR. Ascending means the satellite is flying from south to north and looking to the usually to the right, which is to the east. And descending is flying from north to south and looking to the west. This is for Sentinel-1. Actually, ISCE will have a left-looking radar, which is cool, but which means I'm just going to have to stop assuming that people know which way the satellite is pointing. But if you have, anyway, from ascending and descending geometries in the same satellite, the radars are pointing in different directions between those two. And you can actually use that to solve for things like the vertical movement and east-west movement of the ground. So this exercise is trying to show you how to think in those terms and how to actually extract perhaps more meaningful information out of the data that you've processed. And we'll finish the day with something which is quite exciting, which is a preview of the ISCE software. So most of what we're covering in this course is going to be using ISCE 2, but ISCE is in development and in an advanced stage of development. It's going to be the software that is used to process data from ISAR, which launched 2 weeks ago. So in the upcoming weeks and months, this software will be operational, and so we're going to show you what is coming in that mold, and really this might be the last time we teach ISCE 2 before ISCE 3 comes on stream. So we're going to show you a glimpse of the future. And then day 5, as Yunjun said at the beginning, is mostly the time series day. And so Yunjun will lead the first 2 sessions on using MintPy, which is software that he has developed. He's the main developer of. And that will be taking large volumes of input interferograms and turning them into an INSAR time series of displacements, and then also fitting velocities to those. And he will show you all the tricks and tweaks that you can use to make your time series better, how you can control for errors and either correct them or remove the offending data, and show you all the sort of the inner workings and knobs and buttons that you can push and tweak to make your time series work better. Then we'll have Scott and Yunjun showing us how you can use Opera products in MintPy. Opera, as Scott already mentioned earlier, is the latest and greatest thing coming from NASA, which is essentially turning a lot of interferograms from the whole continent of North America, excluding most of Canada, into displacement time series. Every epoch, every acquisition of the satellite, you have a new calculation of the displacement of the surface in North America. And this data set can be analyzed within MintPy. So we're going to show you how to do that. Actually, I don't know how to do that yet, so I'm really excited to learn about that. And then the final session will be led by Scott and Sarah, showing us how the underlying software that produced the Opera displacement products works. And that software is called Dolphin. And it is also something I don't know how to do. I'm also excited to hear about. But this is a PSDS code. So what that means is persistent scatterer and distributed scatterer. Typically, MintPy is a distributed scatterer code. Persistent scatterers are special pixels in SAR data that are very, very stable in terms of their amplitude and phase response. And there are special things that you can do with those pixels that you can't do with normal interferograms. So this software incorporates the best of both approaches, and will give you the most comprehensive time series results. So I'm very happy to have this in the course and to learn it myself. Okay, and then listed at the end after all this are the supplemental things which are not yet uploaded to the current repository on GitHub, but will find their way there by the time the course starts next week. There are materials on using GDAL to manipulate imagery data. Of course, all of the interferograms we process are imagery, so these are things that you can use to play around with the data that you processed. This used to be part of the main course, and now is in the supplemental stuff, and there are videos of people presenting some of these things from back in the day. We have a much more comprehensive SAR theory notebook, which was written by Paul Rosen, who used to be one of the instructors of this course, but now is way too busy with being the ISCE project scientist to be involved in the course this year. This is a notebook in which you process a SAR image. Basically, it has the components of a SAR processor sort of encoded into it. So for those of you who want to nerd out on the real details of how you focus a SAR image, this is the place to go. We have a module on strip map data processing. It's a different workflow within the ISCE software, which allows you to process other data sets. This particular one is using ALOS-1 data. It's a Japanese satellite, L-band, an archive which is available through the Alaska Satellite Facility. There has its own special requirements for processing, and one of those things is in the module that follows it, which is the ionosphere correction. If you're using data with a long radar wavelength, those data are quite susceptible to distortions from the ionosphere, and you can basically use some of the properties of the data themselves to correct for this. And we have a whole module on how to do that. We have a lecture on measuring glacier velocities for people who are interested in using SAR data and InSAR for that purpose. There's a lecture for you. And we have a placeholder here at the end, which is about software installation. We haven't produced this material yet. We have actually notes in the syllabus document reminding ourselves that we still have to do this. But we will give you some instructions on how to use Conda, which is a package installer that is available to people using various computer platforms. You can use Conda to install some of the software yourself. Okay, at the end we have a description of post-course. So the two things we would like you to do will be linked here at the end of the course, the evaluation and also a test of your knowledge. We'll have a reminder. We're currently talking about how long we will leave the system running for people to use at the end of the course. Usually it's 1 or 2 weeks. We'll give you the exact end date when the system will be taken down here once we have decided on what it is. There's still been some discussions about how much money we have in our budget to leave the system running for longer. And then at the end here is some description of what we can offer you in terms of participation credit for this course. We're experimenting with things called micro-credentials, which are some little certificates saying you did certain things. And also in the past, we've emailed out certificates for participation in this course, so long as people meet certain conditions. And those include completing 70% of the homeworks. So there are 10 of them, so you have to do at least 7. And all of the surveys, the pre-survey and the 2 post-surveys. Otherwise, that we don't know how well you did, right? So if you're interested in getting a certificate for the course, please do take the pre-course survey right away. And then once the course is done, take the 2 post-course surveys. I should also say with that survey that the quiz on your InSAR knowledge, we don't care if you get the questions wrong. It's not supposed to be a test of your ability as a scientist. It's more a kind of a survey of your knowledge of the material coming in, so that we can see how well you do by the end. In some ways, it would be better for us actually if you did badly on the on the initial survey, because we're looking to see how the course has enabled you to learn these concepts better. Not that I'm advocating for you to get the questions wrong. We want to know what you know. And that is the syllabus. If there are any questions about any of this, please ask. One thing I'm remembering now that Melissa asked me to point out to you is that we do not have a place for you to submit your pre-course materials. There is nowhere for you to turn in homeworks for this. And in some sense, it doesn't really matter. This is mostly information for your benefit that we are not going to assess you on. This is kind of background information. The one and only thing that we really care about you doing and completing for sure is this module here, where you can go in and actually try and use your credentials and download data. If this all works for you, then everything else in the course should work for you as well. But if this doesn't work and you get into the course next week, it can often be the case that people are sitting on their hands because they can't actually run some of the modules, and that is a problem potentially. So please get this completed before we start, especially before we start Tuesday. That's where it will become mission critical that you have those permissions and things set up. So that was a lot of me talking. Does anyone have any questions? The chat has been very quiet, which is impressive. Maybe, well, I know that you're not all in the Pacific time zone, so it's not all early in the morning for you. It certainly feels a bit early for me. Yeah.
Question in the Q&A.
Oh, I didn't know there was a Q&A.
It says, curious to know about how NISAR's left-looking SAR configuration influences layover and shadowing in mountainous terrain compared to right-looking.
It will have the same problems, but in a different direction. So for those of you, layover and shadowing are issues that SAR has if you have a slope that you're trying to image with it. If the ground is steeper than a certain angle, then you can't see behind it, basically, and also the topography looks like it's folded over in the direction of the look direction. So the same mountain, if it has asymmetric, potentially might lay over in one direction and not in the other. But no, it's whichever way the satellite is pointing, it's the slopes and the direction of the look that are facing the look direction that are the ones that matter for layover. Yeah, you can go and read the phenomenology notebook for a description of what layover is. Was that Massiv's question? I see that hands have been lowered.
I think he asked his question in the Q&A and I'm answering it.
Okay. Fantastic. The fact that there are no questions means I must have been extremely clear, I'm guessing.
So there are a few additional questions now, I think. It just get answered, marked as answered.
Yeah, I just answered them.
Fantastic. Because if there's nothing else to talk about, we can release you all to get stuck into your pre-course materials. So maybe this is time for us to end this call and I can go and have my breakfast.
I may just want to remind everyone to please make sure to sign up your account on the Earthscope, and I believe on some DEM as well. I think that is on the pre-course and it's important. Otherwise, you might not be able to run your data processing on live with us. So please make sure that your account is set up correctly, and then test your notebook, run all the pre-coursing. That's very important.
Thanks for the reminder, Yunjin. Yeah, if you take one message home from this session, is that please run the last module of the pre-course, set up your accounts and test them to make sure that the data downloads properly. And read. I tried to put some context in that the data download notebook of like what could go wrong and how to fix it. If you're registered for university credit, oh, this is a good question here. I see from Thomas. If you're registered for university credit, you have to complete everything. all of the homeworks, not just most of them, all of the surveys. And you'd be amazed how many people have signed up for this in the past and then not completed the work. So please make sure you do everything.
And I was going to say, just a reminder to everyone that if you have issues with OSL, just to remember to post those to the Slack, because that's the only place, and the InSAR course channel, not me. That's the only place that our experts are looking right now, because it tracks the information as they go. But Moodle questions or Zoom questions or any of that stuff, that can be directed to courses@earthscope.org.
Thanks, Melissa. And thanks everyone for coming. We'll see you all next week, and we're going to have fun.
Bye, everyone. See you next week.
See you next week.